Hello students, today we are going to understand how to build the Huffman tree, which is a source encoder. Consider the five source symbols of a discrete memoryless source and their probabilities are shown in table below. Construct Huffman code tree to find code words, also find average code word length and average information per message. Now the messages given are M1, M2, M3, M4, M5 and probabilities are 0.4, 0.2, 0.2, 0.1, 0.1. So the purpose of this video is to understand how to construct the Huffman tree, not to go in detail of calculation of average code word length and average information per message, because this we have understood in depth in the previous videos where in Shannon Fano code we have calculated these two values. The procedure is same. So let us take the problem. So first step of Huffman tree is to arrange the probabilities in the descending order. The probabilities given are 0.4, 0.2, 0.2, 0.1, 0.1. So write down the probabilities. 0.4 is the highest, so it is on the top. Gives sufficient space between two probabilities, so 0.2, then 0.2, 0.1, 0.1. So this is the first step. They have already given in the descending order, so we have just written it as it is. But if it is not given in the descending order, you have to arrange it in the descending order. Now the second step is you have to do the addition of lowest two probabilities and assign here 0 and 1. So why 0 and 1? Because there are only two levels where we are doing the coding. That is, we are in code we will get only 0 and 1. That's why only two you have to do the addition of lower two probabilities. Now after that, here you write down the summation of these probabilities. Now this summation is 0.2. Now in this step, in second step, you have to you in every step you need three probabilities. So stretch it forward, stretch it forward. Okay, so this is the second step. Now this is 0.2, this is 0.2, this is 0.2. If you want so 0.2, now this 0.2, 0.2, 0.2, these are similar, but you keep in mind that you have to take this 0.2 upward of these two, because it can be proved that if you take this summation upward, your efficiency will increase. Coding efficiency or will is definitely going to be increased. That's why this is the protocol, that you have to take the addition to the above the probabilities if the probabilities are similar. Okay, so we will take this 0.2 upward here. Now this 0.2, this 0.2. Now you have now you have with two lower probabilities. So then again add it. So here 0, here 1. Now this addition is 0.4. Now you have with 0.4, 0.2, this is 0.2, this is 0.4, here this is 0.2, this is 0.2, this is 0.2. Okay, now you have with two probabilities, so you need 3. Okay, so take this 0.4 here again. So you have with 0.4. Now again you have to decide who has to take upward. Now this is 0.4, this is 0.2, 0.4. Similar is 0.4 and 0.4. Again, every time you are arranging the probabilities in descending order. Here, what happened? These three are similar. So summation we have taken upward. Now here, 0.4 and 0.4 are similar. So the sum 0.4, the 0.4 which has come by the addition, you have to take upward. So this 0.4 upward. This 0.4, this 0.2. Now after this you can do the addition. So 0, 1. Now here you are getting 0.6, 0.6. And what is this? This is 0.4. Now there are remain are only 2. So so again what you have to arrange it in the descending order. That means 0.4 0.6 you have to take upward and 0.4 lower. So this is 0.6. This is 0.4. So if you have done the addition, you have to give 0 to the upper one and 1 to the lower one. So this addition is addition of all probabilities sum to 1. So this is how the Huffman tree is constructed. Now what you understand that in this is first step, the probabilities are in descending order. Then you have added, you got 3.2, then sum you have taken upward. Okay, here after that you got this 2 as lower, you done the sum here 0.4. Whenever you do the sum, give 0 and 1. Then again you are encountered with 0.4, 0.4 similar. So sum is this one. 0.4 coming by the sum is this one. Take it upward. And then here you got 0.4, 0.4, 0.2. Here you got 2 lower probabilities. Add it. Whenever you do the addition, give 0 and 1. 0.6, 0.4. Now 0.6 is higher probability. Take it out upward. 0.4 is lower. Whenever then you are going to add it. Whenever you do the addition, give 0 and 1 to the uppermost 0 and lowermost 1. So this is the Huffman tree. Now let us see how the codes are generated. So in the books they say that go like this to search for the code, but I found that this is hard to write the code. It's better to write the code like this. So go from this instead of this and do one change so that you will get the similar answer. So rough work, I can say roughly, because in books they say that go from there from this side to this side, but I tried many times, but I feel that it will be hard and complex to go from this side to this side. So rough work for the 0.4, start from 0.4 here. So here you encountered 0, then 0. This one is not amongst this 0 and 1. This is the addition 1. So this is not binary 1, or we can say this is not included in the code. So you got 0 and 0. This one is corresponds to like these additions. So you got 0 and 0. Next 0.2, 0 and 1. 0.2, this 0.2, 1 and 1. Point 1, 0, 1, 0. Point 1, 1, 1, 1. That means you have to reach here. So many times don't write this one. It will be a confusion to you. Not needed to write this one, because your answer should not be wrong. So you have to do such things. You have to skip such things uh, that will make your answer wrong. So it will be a confusion. You can take this one. So not needed to consider this. Okay, this one. So where we were, 1, then 1, then 1. So triple 1. This is rough work, because books are saying that, because if you write down like this, it is also right, because Huffman is not a unique code. So it is right, but many times invigilator or the paper assessors will come with the particular answers they have provided with. So many times they will not give you the marks for this coding. So what you have to do, as per the books, you have to write 1 0. That means you have to start from here, 1, then 1, 0. First write 0, then 1 and 0, then 1 1 1. Okay, these are similar, so you are not observing any change here. So 1, so you have to start from here and write like this. So this is the answer as per the books. So this is the code. I hope you understood how to construct the Huffman code, and we are going to solve 2 to 3 problems, so that it will be again more useful, or you will imbibe with the concept very perfectly, or correctly, I can say, because practice makes man perfect. So only one problem will not give you that confidence to use to solve the Huffman tree. So we are going to solve 2 to 3 problems on this, but this is the base problem. You have to see this problem many times, so that other problems you will easily solve. So what we understood, summation you have to take upward. You want 3 probabilities. Again, these probabilities should be in descending order. Whenever you do the sum, assign 0 and 1. Okay, so here the same thing is written. So this is the code words. Now H, entropy. So I am not going to, because it is already 13 minutes we have covered. So this we have solved many times in the Shannon-Fano code. So H is pi log of 1 by pi, log 2 of 1 by pi. So all the probabilities, point 2 has come for 2 times, point 1 has come for 2 times, into, so it is multiplied by with 2. Log of 2 means 1 log of 2x. So in every problem I will write down this. So log of 2x, anything is nothing but log of x divided by log 2. So what is this? Log to the base 10. Log to the base 10. Okay. So we have discussed about it many times. So these values are put. You got 2.1219. Average code word length is LIPI. 0.4 is with how many number of bits? It is with 2 bits. 0.2 is with 2 bits. So 0.2 is with 2 bits. So 0.2 again is with 2 bits. 0.1 is with 3 bits. 0.1 is with 3 bits. Pi, Li, and H is P log 1 by Pi. This much you remember. H is P log 1 by Pi. So whatever the probabilities are given, you arrange it like Pi log of 1 by Pi. And L is Pi Li. 0.4 probability is assigned with 2 bits, 0 0 like that. So LU got 2.2 bits per symbols. Actually they have given it per message, but here they have written it symbols. So write down symbols. Whatever they have given na, it may be wrong, it should be symbols. So bits per symbols. If they have given messages, then bits per messages. Efficiency is H by L. So that is into 100%. So 96.45%. So this is for the Huffman code. So if you like this video, give a thumbs up to this video and consider subscribing to the video so that more such topics will be explored on this channel. Thank you.